Predict the products of the following reactions. So we have an acid-base reaction here. We have to figure out which one's the acid, which one's the base, and then what's the reaction going to look like. So here we go. We have HF, okay, HF, and we have Br negative. So we have to figure out which is the acid. Well, I know this is the acid, but let's check anyway. So on here we have HF, and Br negative is Br negative. Where are you? Must be down here. Well, I can't find it. So it's not on this one. Interesting. Hydrobromic acid. Anyway, it was HF. The conjugate acid or base is going to be that, F negative. So let's write that down. So HF, which is the acid, is going to become the conjugate base, which is F negative, aqueous. Now remember that it loses that H and it gives it to the base. So this is the base. And that base now is going to become HBr. Because H, a proton has a positive and this is a negative, it's going to be neutral. It's going to be aqueous, and bam, that's the reaction. All right, let's try another one. So HPO4, 2 negative, and HCl. Okay, HCl stands out to me as being an acid. This could also probably be an acid, but let's check. So let's get this. There we go. Okay, where are you? So we got our friend here, HPO4, 2 negative. Let's find that. HPO4, 2 negative. Nope. HPO4, 2 negative. I can't even find it on here. So let's look for HCl then. Oh, it's the strongest acid. Okay, so then this one here has to for sure be the acid because it's the top. It's on the top, which means this is the base. Acids donate a hydrogen, so this hydrogen is going to leave and it's going to go onto here. And when it does that, the acid is then going to become the conjugate base. Okay, and the conjugate acid of the base has an extra hydrogen, so now it's going to be H2 because there is an H here, and you put this H on there, it's H2, PO4. Okay, H2, PO4. It's a 2 negative charge, but it only gained 1 positive H, so it's going to be a negative still. Aqueous. Yeah. All right. Balance. 1, 2, 2. It's balanced. Perfect. Okay. Let's try another one. Why not? So we have CO3, 2 negative, and HNO3. So we go over here. HNO3 is a strong acid. There's no CO3, 2 negative up here. So then that's the acid, which means this has to be a base. Let's look for this one here though. CO3, 2 negative, there you go. So that's going to be that, and then the conjugate acid of that is HCO3 negative. So that's nice. Let's put the conjugate base first for what this one here turns into. So it's going to be NO3 negative. And we know that because look. Perfect. And CO3, 2 negative goes from there to that. So that's going to be HCO3 negative. Okay, and that's going to be the conjugate acid. Bam. Might as well do one more. HNO3 and H2O. Okay, so which one's higher up? Okay, so we do have H2O in this acid side. It's right there. But HNO3 is right there. It's a stronger acid. So this is the acid, and this is going to be, find it over here, the base. So we're going to use this as an acid. Okay, HNO3 becomes NO3 negative. And that's the conjugate base, so that becomes that. Okay, and water becomes H3O positive. So this is the base in this case. And it's going to become H3O positive. That's the conjugate acid. Bam. And there we go. So hopefully that was helpful.